So how are we going to perform vector addition when two or more vectors are given? So remember that we already have an example for adding vectors, for adding two vectors. But how about when adding two or more than two vectors? So anong gagawin natin? So we can use different methods in adding two or more vectors. So we have the parallelogram method, we also have the polygon method, and we have the component method. So in this video, we are going to perform adding more than two vectors using the polygon method. So using this problem, so our sample problem number 2, 4 vectors show the direction of forces acting on a body. So determine the magnitude and the direction of the resultant if force number 1, force vector 1 is 10 newtons 45 degrees north of east, force vector 2 is 5 newtons 10 degrees south of east, and force number 3 is 6 newtons east, force 4 is 6 newtons 20 degrees south of west. So we want to know our resultant force. So the resultant force is unknown. So let us use the scale of 0.5 cm is to 1 centimeter. So therefore, every 5 centimeter in our ruler represents 1 Newton. So second step, so of course, is to locate the vectors in our Cartesian plane. So again, we use Cartesian plane to visualize the direction. So if you don't want to use the Cartesian plane and you just want to measure to draw a diagram of these vectors, then you can also do it. But in our case, let us use the Cartesian plane so that we will be guided with the direction of our vectors. So let us draw first force vector number 1. So force vector number 1 is 10 newtons 45 degrees north of east. So since it is at an angle, then we need to measure first the angle so that we will be guided when we are measuring the magnitude. So first, yan. So mark the angle. We have here, ayan yung 45 degrees. So therefore, we'll use this as a reference for sketching 10 newtons of force. So ayan. So this will be our force vector number 1. So sabi natin, every half centimeter or every 0.5 centimeter represents 1 Newton. So therefore, ito yung 1 Newton, 2, 3, 4, 5, 6, 7, 8, 9, and 10 newtons. So that will be our force vector number 1. So F of 1 is 10 newtons, 45 degrees, and our direction is north with respect to our east line. So to guide us with sketching our succeeding vector. So nakita naman kasi natin na yung since the first vector is already exist at an angle. So mahirapan tayo basta na lang tayo mag-measure dito ng another force vector with an angle. So let us create another smaller Cartesian plane. So there. Okay, so from the tip of our previous vector, let us draw yan. Meron tayong new, north, east, south, and west. So yan. So yan yung basihan natin for sketching our next vector. So vector number 2 is 5 newtons, 10 degrees south of east. So asan ba yung south of east? So yung south of east nitong bagong Cartesian plane natin, smaller Cartesian plane, is here. So ayan. So we need to measure 10 degrees with respect to the east line of this Cartesian plane. So let us now use our protractor. Ayan. To measure 10 degrees. So meron na tayo dito. So we already marked the 10 degree angle. So with respect to our east line. So ayan yung northeast south, and west. So, align natin yung protractor with our Cartesian plane and then measure 10 degrees. So, ayan yung 10 degrees natin with respect to this smaller Cartesian plane. Okay, so since we already marked the angle, let us now sketch a 5 Newton force. So, dito, again, every half centimeter represents 1 Newton. So, therefore, ito 1 Newton, 2, 3, 4, and 5. So, hanggang dito lang yung ating force vector number 2. So, i-drawing na natin. Ayan. So, that is our force vector number 2, which is 5 newtons, 10 degrees south of east line. So, next step is to just repeat the process. So, since we have more than 2 vectors, then kung anong ginawa natin dito sa ating previous vector, gawin din natin dito sa mga succeeding vectors. So, let us now draw or another smaller Cartesian plane. Yan, baby Cartesian plane dyan. So, let us use this smaller Cartesian plane to locate force vector number 3. So, force vector number 3 is 6 newtons east. So, since wala namang angle, then yung ano natin, yung force vector number 3 will just be a horizontal line, straight horizontal line. So, 3 newtons, ayan, ay 6 newtons rather, 6 newtons. So, therefore, we have here 1, 2, 3, 4, 5, and 6. So, that's our force vector number 3. And then, for force vector number 4, so, linipat na natin dito yung ating, smaller, ang tawag nga dito, smaller Cartesian plane. Force vector number 4 is directed 20 degrees south of west. So, 20 degrees south of west. So, dito, meron tayo, andito yung Cartesian plane natin. And, south of west is here. So, somewhere here. Since this is south and this is the west line, we need to measure 20 degrees with respect to our west line. So, we have here 10, 20. So, andito dapat yung, yung mark, 20 degree angle natin. Ayan. So, let us now sketch force vector number 4, which is 6 newtons south of west. So, now that we have the 4 vectors, we have located the given vectors, it is now time to close the polygon. So, the closure again, so the last vector na idodrawing natin will represent the resultant vector, yung vector that will close the diagram. So, will create the polygon. Okay. So, from the initial point, let us sketch the resultant vector. So, andito yung tail at andito yung head ng ating resultant vector. So, while you are sketching, you can already measure the magnitude of your resultant vector. So, bilangin natin kung ano ba yung magnitude ni resultant vector. So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, therefore, the magnitude of our resultant force vector is 13 newtons. So, ayan. So, that will be our resultant vector, which is 13 newtons. So, ano yung direction niya? So, we need to look for the angle of this resultant vector with respect to our east line. Kasi yun, andyan siya, di ba? Ano ba itong angle na nagawa nitong resultant force vector with respect to our east line? So, let us now measure the angle. So, the angle of the resultant vector is, yan, approximately nasa 18 degrees. Kasi ito yung 20, this is 19, and andyan siya, 18. So, kapag sa, in real situation, of course, you need to apply the uncertainties. So dito, we're just estimating it, assuming it to be approximately 18 degrees. So kapag sa actual situation, you need to apply yung previous concepts na natutunan natin, which is to apply the uncertainties and measurements. So you apply mo yung yung pwedeng maximum error or minimum error, maximum uncertainty or minimum uncertainty. But in this case, we assume it to be 18 degrees with respect to our east line. So, ayan. So now, we now know that our force vector, our resultant force vector is 13 newtons, 18 degrees, and the direction is north of east line. So, north of east. Yan. So, kapag inad natin si force vector 1 plus force vector 2 plus force vector 3 plus force vector 4, it will result to 13 newtons, 18 degrees north of east line. So, yung value nito are this one. So, hindi ko na linagay yung value kasi mahaba. So, each of these vectors, ayan yung value, respective value nila. So, anong implication nito? So, for example, we have the particle here. We have a particle here, and then we have these forces acting on it. So, yan yung mga force kanina na nilagay natin sa diagram. So, we have a force vector, which is 45 degrees north of east. So, 10 newtons siya. And then, we have 6 newton acting towards east. And then, we have here 5 newton. So, ayan. So, applied 10 degrees south of east. And then, we have here our force vector natin, which is 6 newton, 20 degrees south of west. So, for example, they are a pushing force. So, diba? Because force can be a push or it can be a pull. So, sabihin na natin na they are all pushing this particle. So, ngayon, ano yung magiging final motion nitong particle na to? So, given that these forces are applied to this particle. So, when we add all of those forces, diba? So, when we add force 1, force 2, force 3, and then force 4, the resultant force is 13 newtons, 18 degrees north of east. So, we expect that this particle will move 18 degrees north of east since our resultant force is towards this direction. So, ayan yung ating resultant force. And then, since yan yung resultant force natin, then it will push our particle to move towards the same direction as our resultant force. Okay. So, that will end this solution for our sample problem number 2. So, in our next video, we are going to discuss how to perform vector addition using component method.